Okay, so the first question, please write it down, is what is the sum of the geometric, please write this down, what is the sum of the geometric sequence? Sum of the geometric sequence. So here's the sequence. This first problem, I'm going to show you the slow way that you will not use, but just so you have an idea of what this looks like. So this really is a list. It's 3, 12, 48, and then there's these numbers I need to fill in, and the list ends with 3076. How do I find the missing numbers? Well, the first thing you do is you always take the second number and you divide it by the first number in that order. So 12 divided by 3 is 4. That is your rate. It's consistent to get from one number to the next. In this particular problem, we are going to multiply by 4. So as you can watch here, just watch me do the first one, please. I'm going to take 3 times 4, that's the second number, times 4, that's the third number. And the cool thing about our calculators is once you do something twice, it remembers the pattern. I press enter, 192. Press enter, 768. Press enter, and there's my last number. So in fact, this is the 6th number in this sequence. Okay? We represent the number in the sequence with the letter N. The first number in this sequence is 3. Our goal is to find the sum. That means add them up. So the slow way of doing that, which seems like the simple way when there's not decimals, fractions, or a large amount to add up, is to simply add them up like I'm doing. And I'm going to show you just so we can check what the answer actually will be. So I know the sum of these numbers, and I think I put one in wrong. Let me try once again. 3 plus 12, 48, 92. The sum of these numbers is 4,000. What am I put? Oh, my fault. Change this up here. Change this to a 2. I meant for this to be a 2. 4,095. That would be an incorrect geometric sequence if it was not a 2. Okay. So, how do we do this by simply not just adding up one number and then the next number? This is the one you want to write down. This is the general formula. And so we start with what is the first number in this sequence. It is a 3. The rate for this problem, how do I go from one number to the next? I'm multiplying by 4. This particular sequence has not 4 numbers like we see, because remember there's 2 hidden ones. Has 6 numbers in to get to 3072, so a 6 goes up above. And so this says, let's add up the first 6 numbers. So the initial number times 1 minus the rate of 4, raise the 6 over 1 minus 4. Now, watch it on the calculator. I'm going to point out, if you can just watch, where the most common mistakes are made. You start with the numerator inside. So it's 1 subtract 4 to the 6, just watching. And here's where the mistake is made. Students forget to put this portion in parentheses. Without parentheses in the denominator, it will be wrong. Take it times the number out front, and there is your 4,095, the same way as if you just added them up. Okay? Your initial understanding, thumbs up or thumbs down right now? Thumbs up or thumbs down? Raise it high so I can see, please. Thank you. Okay, please write down the next one with me. Second. Okay, I start by writing down what's the first number in this geometric sequence. It is a 4. The next step will be to identify what the rate is. That means, how do I go from one number to the next? To get the rate, you take the second number and you divide it by the first number. 32 divided by 4 is 8. And now I need to identify how many numbers are in this sequence. A common mistake is students say 4 because they see 4 numbers. There's numbers in here represented by the dot, 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 okay? So there's a formula you can use to identify how many numbers to get to this one. It involves something called the logarithm, which we haven't learned yet. So we're going to do the simple way. Grab your calculator. Take 4 times 8. Press enter. That's the second number, and we're literally just going to count out loud. Times 8 again. That's the third number. And now we've done this twice. Every time I press enter, it will do it for me. So this is the third number. 4, 5, 6. This just happens to be the 6th number. So even though we used 6 last time, we're using 6 again this time. So n equals 6. So I'm going to take the first 6 numbers in this sequence. The first number is 4. 1 subtract a rate of 8, 1 subtract 8, and my n goes up above. Grabbing the calculator once again, it's going to be 1 subtract 8 to the 6th. Remember that when you divide, you need to put in parentheses 1 subtract 8, and then take it times the original first number in the geometric sequence, which is 4. So how do we write this? It means the first 6 numbers in this sequence would add up to 149,796. Can you please check with your partner while I write down the next problem to make sure they understand? Yes. It's the sum of them. The sum? Yes, the sum. Okay, here's your next one. Okay, your next problem is with fractions. So I'd like you to attempt this problem with your partner. Done or not done, I'm going to stop you after 2 minutes. I'm going to go work with Evelyn. You have 2 minutes to get the best you can, as far as you can get. You're finding the sum of this geometric sequence, and then I'll go over it with you. Begin. Do not round. Do not round. These are the fractions you can't. remaining? Okay, gonna have you stop. Totally fine that you're not done. Hold up for 1 second, please. So let's go about this together. You ready? I'd like you to take this and turn this into a decimal. Take 729 and divide it by 64. Do you have approximately 11.3906? I guess exactly looks like that. Okay, so I'm going to grab the calculator, and I'm going to take 2 divided by 3, and I'm going to, excuse me, let me start back here. Go from the beginning. Here's your initial number. Don't round it like Mari asked. That's a great question. Then I'm going to find the rate. Take the second number, divided by the first. So 1 divided by 2/3 in parentheses gives you a rate of 1.5. Okay, so here we go. 2 divided by 3, enter, times 1.5. Okay, got it. That's my second one. Times 1.5. Okay, 1.5 is the same as 3/2. So this is the third. I've done it twice. Now this is the cool part. So I've done it twice. I'm on the third one right now. 4th, 5th, 6th, 7th, 8th. So n is 8. Again, there's a formula we could use, but we have not learned how to work with logs yet, so this is how we will do it. I want to add up the first 8 numbers in this geometric sequence. It starts with the first number. 1 subtract the rate, 1 subtract the rate, and then this is to the 8th. So this is adding up the first 8 digits in this geometric sequence. 1 subtract 1.5 raised to the 8th. That's the numerator. Divided by 1 subtract 1.5. And now take that times the number out front, which in parentheses is 2/3. And I'm going to see if I can turn that back into a fraction, which I can. So the first 8 digits or terms in this sequence add up to 6,305 divided by 192. 1 to 5 right now, your level of understanding with that particular problem, 1 to 5. Okay, this one is not a race. Please take your calculator, your paper, and your, hold on, don't move yet, and something to write with. Do not sit down, just stand up somewhere with your partner. Go ahead, please. Yes, your number partner. Okay, please find the sum of this geometric sequence with your partner. You have 2 minutes. Begin. I'm sure if you need to. If you need to. Make sure you're talking to your partner. Martini, do you have a partner? Okay, good, good. Just making sure. So each time you look up here. Turn it back into a fraction, see if you have the same number that I do. Okay, then maybe I made a mistake. Let me check. Easily could have made a mistake. Do you have n being 5? Okay, 1 subtract 2.1 raised to the 5th. I could have easily made a mistake. Divided by 1 subtract 2.1. Good so far? Yeah. Times the number outside, which is 4.5. Is this the number you have? Yes. Okay, for me, I hit math fraction, enter, enter, and it gives me this fraction. Yours does not? No. Okay. Some of them do, some of them don't. It must be how they are currently programmed. Just know that if you have this answer, 162.98595, you are correct as well. 1 through 5, your level of understanding right now. Hands up high so I know where we stand. Okay, this time you are going to take a problem as if it is a test question. Are you ready? Don't do anything yet. Just write down. Okay, so I just provided for you 3 numbers, the first 3 numbers in a geometric sequence. I provided the first 3 numbers. And this particular question says, what is the sum of the first 6 of the sequence? On your own, see what you can do. Stop what you're doing, look at my work, and talk to your partner in the next 30 seconds. I'll answer any question the class has. Go ahead, talking to your numbered partner. Won't say, do you have a numbered partner? Is it Victor? Okay, go ahead. How did I get 6? Because I told you bake going well?
It goes up more well if I had some stuff.
Well, you have Miss Bradley last period of the day. Any better? No. This is all wonderful to learn. It makes you think. How many of you have to think? You just can't go through the makes you think. Like some of you are like, oh, better not raise my hand. Nobody else is raising it. But if you can't apply it to a real life problem, then it's kind of like useless knowledge. So here we go. You ready? Let's see how many of you are great common sense thinkers. There's more than one way to think about processing this information to get your answer. So, Evelyn, you're 16 or 17? This looks still around. Okay, so Evelyn is going to have a big 18th birthday. Forget that, Evelyn's 17 turning 18 soon. Okay, 17 turning 18, and she's going to throw a large party, and she's very excited, and she's worried that people aren't going to come. Okay, so what she does, listening closely, is she goes to student government, because that's where her pals are. Okay, and she takes a big stack of invitations, and there are, how many juniors in your class? There's 12 juniors in student government. She brings this big stack of invitations. You may want to write some of just the basic information down. And she brings them to student government, and she is one of 12. So she goes to the 11 other juniors in student government, and she says, okay, here's what I need you to do. You need to help me promote my 18th birthday party. So I'm going to give each of you a stack of invitations. And I want you to find your 3 closest friends outside of student government, and take the stack and split it up among those 3 friends. And then give them the directions to find their 3 closest friends and pass out 3 more sets of invitations. And so you're going to continue to do that for 4 rounds of passing out invitations. So the first round, how many people got invitations? 11. And then each one of those was told to pass out to how many people? 3. And then each one of those people was told to pass out to how many people? 3. You're going to do that for 4 rounds or 4 levels. We need to assume a few things. Don't consider Evelyn as having an invitation for her own party. We don't care about that, okay? And assume that no student is going to receive a duplicate invitation. So if somebody goes to give somebody an invitation and they already have one, they can't consider giving that person an invitation, okay? My question is, after 4 rounds of passing out invitations, how many people have an invitation in their hand for Evelyn's 18th birthday bash? Ready? With your partner, figure out a strategy to find that out. You have 2 minutes. Do this with visualizations. You ready? Make sure you're not taking your phone out. I don't want to take that away and give it back to you tomorrow. Okay, so here's the first person, right? Oh, so hold on. There's Evelyn. And Evelyn has 11 friends in this first round that receive a stack of invitations. I'm not going to count those. Let's just assume that's 11, okay? Now, what are the instructions for those 11 individuals? So, ready? You have 3 here, 3 here, 3 here, 3. So 3, 3, 3, 3, 11 times is a total of 33. Now what are each one of those people need to do? They need to pass it to? Which brings you up to 99. And what does each one of those 99 people need to do? They need to pass it 3 more, which brings us up to 297. Now, the most common mistake people make is they think that this is the final number. It is the 4th round, but that's how many people received invitations in just the 4th round. You need to add them up to see in total how many invitations were passed out. And the answer is 440 total invitations passed out. Now, what's another way to do this? Okay, we know there's 4 rounds, so start like this. We know there's 4 rounds. We know the initial number goes out to 11. Now, what's the rate? So after the first number is set, which in this case it was 11 friends, after the first number was set, you figure out what are the directions, and it's to give to 3 people. So you're tripling every single one of those. That means your rate is a 3. How could you figure that out? The second number divided by the first. 33 divided by 11 is 3. Okay, please do this on the calculator and see if you come up with 440. Go ahead. You may. You also come up with 440. Okay. So here's the next one. Let's try another one. Go back to your original partner, please. Go ahead. All right, so prom is coming up, and with that would be the opportunity to run for the king and queen and the princess and prince. Leslie, please stand up. If you did not know, it is Leslie's goal to win princess. Go with it, Leslie. Okay? And she's like, but people don't know who I am. So here's what she's going to do. She's going to copy off little things with her picture on it. You guys see people do this, right? Yeah. And then it's going to promote themselves, okay? Sit back down. Please take this take all this information in and write down only the important stuff on your paper. So to spread the word, she hands her 5 closest friends a stack of pictures of herself that say, "Vote for Leslie." She directs her 5 closest friends to give an invitation to their 2 closest friends. And in turn, those 2 closest friends should give invitations to their 2 closest friends, and so on. If no one ever gets a duplicate invitation, not invitation, but a duplicate picture promoting Leslie, how many people have received a picture of Leslie saying, "Vote for Leslie," after the 6th round of pictures have been handed out? With your current partner, figure this out. Go. Did I say 6 rounds to you guys? Yeah. Thank you. Do we come up with 315?